Hello, ma'am. Hello.
Yes.
Hello, ma'am. Can you hear me? Ma'am, regarding assignment 3, I raised two queries. Question number 9 and question number 12.
Where you raised it in the online platform? Like,
Yes, ma'am, in the discussion forum.
oh, okay, okay. I didn't check it. Uh,
But I didn't get any reply from your side.
normal those things. The normal NPTEL TS will be there. They only used to give the answers.
Okay, ma'am. Because question number 9 and 12.
Okay, I will check it once.
Okay.
Yeah, I will inform them. I will let you know.
Okay.
Is this this is the third question? Whatever you raised the doubt.
No, ma'am. Third, 12th, ninth question is about which of the following is a part of its first law?
Okay, I think it's this answer.
In the end semester exam, the
Mm.
final exam, whether we will get any descriptive type questions or only MCQ.
Yeah, you will get descriptive.
Okay. Okay.
Okay, let us start today's section. Okay, so can you please mute
Okay.
it?
Okay, ma'am.
Okay, so we are going to discuss more about the week 3 problems today, like some MCQ as well as some numerical problems also. So this portion includes the defect, diffusion and phase diagrams. Okay. Now So let us discuss it. It is like very easy problems, like MCQ problems, which I have given first here. So first question is, which defect is thermodynamically stable? Can you answer, anyone? Which defect is thermodynamically stable?
Point defect.
Yeah, point defect. So which one is the point defect?
Vacancy.
Yeah, vacancy defect. Yes. So the answer will be vacancy defect. Now, what about the next question? Which of the following are not a two-dimensional defect?
Option C.
Option C and
Grain bonus.
grain boundary is a plane defect, right? It is two-dimensional.
Two student. Then only vacancy.
No, edge
It's
dislocation also. It will come in one dimension.
one time. Okay.
Now, what about the third question? Which of the following statement is not a correct? So the
For
option.
each location, the dislocation is parallel to. That is not effective. C.
So that is wrong, you are saying, right?
Yes, it should be perpendicular if it's a.
Yes, then one more option will be also true. What about the screw dislocation then?
Then D should be. Then D is also not right.
Yes. Now, what about the magnitude of screw dislocation? Actually, there are two more options also actually. The options will be burger pressure and the option will be microscope. So, magnitude of screw dislocation will be given by yeah, burger
Burgers better.
pressure. Now, just say it is correct or not. The fifth question. In screw dislocation, an extra
Wrong.
half plane is inserted inside the crystal. Is it
False.
correct or not? False.
Not correct.
It
False.
will be false. And what about the next question? A defect associated with a mismatch of crystalline orientation from one grain to another adjacent grain is called
Grain boundary.
grain boundary. Yes. Now next. A twin boundary is it will be 3D, 2D or 1D or 0 dimensional. Which one?
2D.
Yeah, twin boundary is 2D defect. Yes. Now next is problem set. Okay, it's like a small numerical problem. Calculate the equilibrium concentration of vacancies in an filament at 100 degrees Celsius. The energy of formation of vacancy is 0.7 electron volt. How to do it? Which formula you have to use it for this one?
Exponential of Q by KT.
Yeah, Arrhenius formula you have to use, right? So it
Yes.
will be
Yes.
NV divided by N is equal to e to the power minus QV divided by RT. Let's put the KT. So substitute all the values here. So first we will write what are the given values and please solve it. Okay. So QV will be what is given 0.7 electron volt. And temperature is already given 100 degrees Celsius. So you can, it will be 373 Kelvin. Okay. Now what what is given? Boltzmann's constant given, it is 8 point, like you can take it as 8.62 times 10 to the power minus 5 electron volt per Kelvin. Now find the value of Nv by N. Please mute yourself. And please write the answer, okay? What, how much you are getting the value. Please, you can keep it in the chat box, otherwise we can.
What is the answer?
How much you are getting?
Still, I am getting a bit absurd value.
No,
Hmm.
it will be e to the power, okay?
Yeah, got it, got it. Hmm. Thank you.
E to the power
3.51
yeah, 3.51 and power,
minus 10.
yeah, correct.
Yeah, sorry to interrupt you. Actually, in last session, we have discussed about this compound microscope, and you told me that you will give the sources.
Yeah,
Uh,
I will upload it in the chat box, okay? It's fine.
okay. And that theta 1 is to theta 2, that solid state
That one
phenomena.
also link I will share you.
Okay, okay, fine. So this link will be available in this chat box.
Yeah, Otherwise, what can I do? You are getting every week YouTube link and the PPT, right? You can access it, I hope.
But it is not there in this PPT. I
Yeah,
mean,
then I will add those links in last slide of the PPT.
okay, okay, thank
Everyone
you.
can access it easily. Like whoever
Thank you.
didn't attend the class also can access it.
Okay, fine, fine.
Now, let us discuss the next problem. Which of the following are correct for a steady state diffusion? There are options: no transfer of mass, concentration profile is linear, concentration gradient is changing, concentration gradient is constant, and diffusion flux is constant. What will be the answers then? Do anyone know? It's for a steady state diffusion is asking.
Linear.
Yes, concentration profile is linear. Then there are two more.
Diffusion flux is constant.
Diffusion flux is constant, and next one more will be there. Then another one is concentration gradient also is constant. Okay, so only it will be linear, right? Now see the next question. The concentration profile for steady state diffusion is given in the figure below, and the diffusion coefficient of an element is given as 6 times 10 to the power minus 11 meter square per second. Calculate the diffusion flux J in kilogram per meter cube second. Okay, so how you will get it? So which formula you have to use first of all?
First law.
No, so it will be J is equal to
Minus D,
minus D
change in
D,
concentration
change in
divided by
concentration by 6 dx.
change
Okay.
in diffusion.
Just tell me one thing, this negative sign is important, I mean, when we are solving this problem.
Like, yeah, it will be.
Hmm.
So now here from the float you have to get the dc by dx value. Capital D is already given in the question, so you can directly substitute it. 6 times minus 11, 10 to the power minus 11, but you have to find the dc value as well as dx value. Okay, so dc value will be c2 minus c1. So what is c2 here, what is c1 here?
4 minus 2.
4 minus 2 or 2 minus 4?
2 minus 4.
Yeah, it will be 2
Yeah,
minus
2
2.
minus 2.
2 minus 2. Okay, and dx value, how it will be? x2 minus x1, it will be 10 to the power minus 3 minus 0, it will be 10 to the power minus 3. Okay, now you got the dx value, dc value and j value. Substitute everything here. Then find the answer.
Two is into 10 to the power minus 8. I mean, what will be the dimension?
Let
अच्छा
me
kg per meter square.
hmm,
Kg per
kg per meter square second.
kg per meter square सही बात है.
Here everything units are perfect only. See, concentration unit also kilogram meter cube only, and position also in meter only. So just you have to do the mathematical part. That's it. It will automatically come the unit.
1.2 into 10 to the power minus 7.
Yeah. The answer will be, just we have to substitute 6 times 10 to the power minus 11 times minus 2 divided by 10 to the power minus 3. The answer will be 1.2 times 10 to the power minus 7 kilogram per meter cube second. Now let us go for the next question. The proportion of phase presence under equilibrium at a particular temperature and concentration of alloy can be deduced using which rule?
Liver rule.
Lever rule. That's very straightforward question from Sar's class. Now next one also, it is very straightforward question. Solver's line is boundary between,
Option C.
yeah, alpha and alpha plus beta. Now what about
Fourth.
now next question, 13th one. In a two component system, if the degree of freedom is 0, what will be the maximum number of phases present in at the constant pressure? So which rule we have to use here?
3.
Gibbs rule. Gibbs
Gibbs
space.
space rule only you have to use. Yes. Now, what will be C value here? The component will be 2. It is given 2 components. And degree of freedom is 0.
0.
So, it will be C plus F is equal to C plus 2, right?
C
But
plus 1.
C plus
here
1.
pressure is constant. So, it will be C plus 1. Now, substitute everything. C plus 0 is equal to 2 plus 1. Then you will get the value P is equal to 3.
3.
Yes. These kind of questions you can expect in the exam. Okay. This question is very
These kind of
important.
questions are good, but that compound microscope is really difficult.
Yes. Yes. But that portion, I think maximum theory kind of questions will come other than problem. It will be most probably easy exam.
For solver's line problem, for solver's line question, the answer was given wrongly in the assignment.
What?
For solver's line, the boundary between alpha and alpha plus 3. For
Uh-huh.
this, for this question, the answer is wrong in the assignment.
Oh, okay. Sometimes it happens actually. Real problem. But you mentioned in the discussion forum they will change. Okay, they will give
Okay.
the mark.
Okay.
That's not. I'm not doing that. You can take care by the normal TA.
Okay.
Now, solve this problem. Yes, already you know the formula. Just do the problem. Okay. So the question is the diffusion coefficient for iron in nickel at 1273 Kelvin is 9.4 times 10 to the power minus 60 meters square per second, and at the 1473 Kelvin is 2.4 times 10 to the power minus 40 meters square per second. Give values of pre-exponential factor D0 and activation energy Q. So this problem, how you will solve? You have to compare those two values and you have to solve it. Okay, so base formula you already know that it will be d is equal to d0 exponential e to the power q divided by rt. Okay, now here what you have to write is, you can write d1. d1 will be what? d0 exponential of minus q divided by rt1, that you can call it as equation 1, and d2 you can write it as d0 exponential minus q divided by rt2. Okay, this you can call it as equation 2. Now what you have to do, you can do d1 divided by d2, so all the terms will cancel, only exponential term will be here. It will be minus q divided by rt1 divided by exponential of minus q divided by rt2. Okay, now you can take log on both sides, natural log, so it will be log d1 by d2, that will be minus q r star divided by 1 over t1 minus 1 over t2. Okay, now you have to substitute the values here and find the q value. Then if you put the q value in the any one of the equation above, you will get the d0 value.
Can you explain it, Sonali?
Yeah, like in the question what is given, the efficient coefficient for two situation is given, one for 1273 Kelvin and another one is for 1473 Kelvin. Okay, so you know the formula, that is d is equal to d0 e to the power minus q by rt, but here you can see the temperature is changing, accordingly d value will be changing, so 2d value will get it, so we can call it as d1 and d2. Now see, d1 will be d0 e to the power minus q divided by rt1, because temperature only here changing. Similarly, d2 will be d0 e to the power minus q by rt2. But your aim is to find the q value and d0 value. To get the two value from these equations, what you have to do? You have to do the division of both of two. So divide those two equation and you will get it exponential of minus q divided by rt1 divided by exponential minus q divided by rt2. Now to avoid the exponential, you have to use logarithm on both sides. So you have to use log on the left hand side also as well as right hand side also. If you use it in right hand side, the exponential will cancel, exponential log will cancel, then what will remaining? qr times 1 over t1 minus 1 over t2 will remain. Now here you have to give the values.
Uh,
Yes,
Q by R or Q
it will be q by r. Yes, yes.
Q by R. Hi, sorry, sorry. Thank you.
Yeah.
What should be the value of R?
8.314 liter.
Is it option C?
Yeah.
Actually, I'm getting 2.53.
2.53. How? Okay, I'll solve it here. So you have to substitute all the values. It will be log 9.4 times 10 to the power minus 16 divided by 2.4 times 10 to the power minus 14, that is equal to minus q divided by 8.314 times 1 over 1273 minus 1 over 1473. Okay, so here from here you will get the q value is 252.5 times 10 to the power 10 to the power 3 joule per mole. Okay, that you can write it as 252.5 kilojoule per mole. Okay, now substitute any one of the equation. D1 will be d0 exponential of minus q divided by rt1. So it will be like 9.4 times 10 to the power minus 16 is equal to d0 exponential of minus 252.5 star 10 to the power 3 divided by 8.314 star 1273. Here you will get the value 2.169097 times 10 to the power minus 5. That you can write as 2.17 times 10 to the power minus 5. all of you solve the next problem. It's also similar kind of. The vacancy concentration in a crystal is 4 times upon increasing the temperature from 127 degrees Celsius to 327 degrees Celsius. The enthalpy of vacancy formation is, the options are given. So how you will solve this problem? Which formula you have to use? Did anyone try?
Yes, ma'am. Exponential of minus q by RT.
Yeah, yes. So here you can write it as n is equal to n star e to the power minus es, and that's your formation, that's it, vacancy formation, es divided by RT. Okay, now here two situations are given, right? One is 4 times and one is normal. So there you have to take again that 4n situation, how it will be, n times e to exponential to the power minus es divided by RT2. That is the only difference.
It should be R or K. I mean,
It's normally taking as R. The formula is R.
actually, QB by KT, na?
Formula is QB by KT.
Here you have to take this R value.
Now, but this method we have to take R. Then only we'll get the answer here.
Like, how can I understand this? When we have to take this R and when we have to take this K value? Uh,
Yeah, I will
Is there
tell
any
you.
thumb rule or I mean,
Yeah, I will tell you. Actually, the relation between this gas constant is Avogadro number times the Boltzmann constant. Okay.
in the previous problem where
That is
this
what I check now. Previous problems also we used RT, right?
no, we used K 8.62 into 10 to the power minus 5.
Wait, that is which problem?
0.7 electron volt. Equal. This one.
Actually, this Boltzmann constant Kb value you can use to for only for one molecule case. Okay. Hmm? When it is
Sorry.
using no, Boltzmann constant Kb, when we are using is if it is only one molecule or one element, then you have to use Kb. Okay. If it is the case of a one mole of like or a number of atoms, then you have to use it for the like one mole of molecules or one mole of atoms.
Its R value is also applicable for one more. 8.314.
R is for one mole.
Huh.
Yes.
This Boltzmann G is also for one mole. Uh, so actually, I'm not getting it, bro.
No, no. Boltzmann constant for one molecule. Okay. R value is for one mole of molecules. Both are different, right? One mole of molecule means it contains Avogadro number of molecules in that. You getting?
No, actually, by seeing this problem, I mean, how can I understand that in this case I have to use R, in this case I have to use this K?
In the options they have given bold, right? So you have to use.
By seeing the dimension of this option.
Yes, based
I
on the
think you
option.
have to count from the option because see the this question whatever we solved for a k value.
It is dimensionless.
No, it is dimensionless in the option, but it's for in an element it is written. Number of molecules can be in that.
In that question, they have mentioned Q in the form of electron volt.
Acha. Yes.
Option A, 13.83 kilojoule.
Option A is not right. Now, how to solve this? Now you have to same equation, you can call it as equation 1, this you can call it as equation 2 divided by 1 over 2. Okay, what you will get it then? Similar way earlier you had to do, you will get it 1 over 4 is equal to e to the power minus es divided by rt1 divided by e to the power minus es divided by rt2. Okay, now do the log on both sides, so you will get log 1 over 4 is equal to minus es divided by 8.314 times 1 over 400 minus 1 over 600. Then you will get the answer as the first option. Okay. Now answer this question. Burgers vector of edge dislocation is perpendicular to dislocation in dislocation line vector. Screw dislocation is perpendicular to the dislocation line vector. Edge dislocation is parallel to the dislocation line vector, and screw dislocation is parallel to the dislocation line vector. What it will be? What is Burger's vector?
Option A and D.
Option A and D. So what is a Burger's vector?
The extra plane of atom. Sorry, the extra plane.
But okay, if you see, okay, this is one
Well,
dislocation, right? It is edge dislocation. How you can see, how you can get the Burgess vector here? So what is edge dislocation? Like extra row of atoms are coming, right? Like this. Hmm? So if you plot like this, okay, let us start to measure from here. We are going to calculate the Burgess vector. Okay, so let us start from here. It will go 1, 2, 3. Now here it is 1, 2, 3 for this side. Okay. Now here 1, 2, 3, 3 cells. Here total we will get 5 cells. Okay. Now see, if it is a normal crystal, what will happen if you go same way? This all will be fine. 3 here, 4 here, 3 here. But if you do 5, it will go out of this. Right. So Burger vector you have to calculate the from the end and to the where we started. So this will be the Burger vector direction. Okay, for edge dislocation it will be perpendicular, and for a screw dislocation it will be parallel. Okay, so here answers will be option A and option D. Now, next one. Thermodynamically stable defect is
vacancy.
vacancy defect. So let us discuss what is each defect here. Okay, what is a vacancy defect? What do you mean by vacancy defect?
Absence of atom.
Yeah, here it will be absence of atoms. Now, what is interstitial solute defect?
A solute in its interstitial position.
Okay, if atoms
Solid.
are arranging, and if any another atom in this place, we can say it as interstitial solute defect, right? Yes. Now, dislocation defect.
That is Burger vector.
Yeah. So it will be like a linear defect.
Hmm.
Hmm? And another kind is Schottky defect. Schottky defect, I think it's not in your syllabus, but it is like it will come for the ceramic materials normally. Okay. Now, here what are zero-dimensional defects? These two are
Vacancy.
Vacancy.
interstitial
Interstitial.
zero-dimensional defect.
Hmm.
Okay. Now, when you will get interstitial solute defect, when you do doping or something, you will get the interstitial solute defect. Okay. So these are the just idea of this. The
Now,
answer
what
is
about the last one?
Schottky defect. Actually, it's not in your syllabus.
It is not, no?
It's
Because
what kind of what dimensional defect? That's a 1 or 2 or 3.
Which one? Schottky defect.
Yes.
You see. It is also like point
zero
defect only. It will be a zero
zero D defect.
dimensional.
Hmm.
Schottky defect also zero
Bo-
dimensional.
uh, both Schottky and Frankel are the zero dimension.
Hmm?
Both Schottky and Frankel,
Yes, right.
both are zero D.
No, one will be point defect and another one will be imperfections in the solid only. Like we can mark this. Yes, it will be coming to the surface, right?
Frankel is 2D.
Frankel 2D. Sir, what did you say? Frankel is 2D.
No, I also don't know. She said it's a planar kind of effect.
Acha, acha. Actually, I also don't know. That's why I asked.
No, Frenkel defect is another form of point defect, right? Like Frenkel defect is what? Atoms is
Yes,
moving.
it's a points defect.
Yes. If it is a point defect, definitely it should come for zero dimensional.
Zero damage.
Okay. Okay. Then no, both are 0D.
Yes. Frenkel defect
Okay.
is like atoms will be there, but one atom from the original position it will go to some other place. It is not coming extra atom here, like this
Okay.
location or
Okay.
inner
Thank
shell.
you.
Yeah. Now, next option, diffusion is the result of,
All of the above.
obviously, right. Random motion of atoms will make diffusion, and concentration gradient also, kinetic energy of atoms also will make the diffusion. So, all of the above is the answer. Now, what about the next problem? It is little bit lengthy.
You got quite lengthy problem.
Quite lengthy, but only you have to use the formula, that's it. The question is, consider an alloy that initially has uniform carbon concentration of 0.25 percentage and it is treated as 950 degrees Celsius and Fahrenheit also given. If the concentration of carbon at the surface is suddenly increased and maintaining at 1.208 percentage, how long will it take to achieve a carbon content of 0.80 weight percentage at a position of 0.5 millimeter below the surface? The diffusion coefficient of carbon in the ion at this temperature is 1.6 times 10 to the power minus 11 meters square per second. Assume that the steel piece is semi-infinite. So, what are the things given? Do you know which formula we have to use? First of all,
It's
first law or
second.
second law?
Second law.
Second law. So, obviously, let us write this the formula. Second law, C of xt is equal to Cs minus C0 your percentage your function of x divided by 2 root of dt. Okay. Now, what are the terms in this? What is Cs? It is surface concentration. Okay. What is C0?
Initial
Initial concentration. Now, this is error function, and what is x? It is thickness. What is d? D is diffusion coefficient, and time is t is time. Okay. So, how you can understand it is a second law or first law? When the time terms included, this is not at all a steady situation. So, that time we have to use the second law.
Sorry, second.
No. If time term is included, then it will be come to the second law. It will be non-steady state. If there is no time dependence, it will be steady state for the situation. Okay, here you can clearly say that time is involving, so you can understand that it will be second law. Okay, now here you have to solve it. So you have to read the question carefully and find the what are the parameters given. Okay, so what is C0 value? So it has a uniform initial carbon concentration is given Z0, that is 0.25. Okay, now Cs value is also given. The surface is suddenly, concentration of the carbon at the surface is suddenly increased to and maintained. So that is Cs value 1.20. Okay. Now the thickness is already given 0.5, and D value is also given 1.6 times 10 to the power minus 11, and Cx of T is also given. It is 0.80 weight percentage. Okay. Now you have to calculate the value of T. So you have to use the above formula. Now substitute all the values. You will reach. I am not going to solve all the steps here, but I can give some hints here. Substitute all these values. You will get C of x comma t minus C0 divided by Cs minus C0 is equal to 1 minus error function of x divided by 2 root of dt. Okay. And do anyone know what is error function of x? Error function of x means the general formula is 2 by root pi integral 0 to x exponential of minus u square du. Okay, this is the general formula. But normally for solving problems, what we will do, there are 3 error functions for each z value. If z value is 0.35, the error of z will be 0.37, and any normal z value we are taking as between, whatever the value we are taking error function as a zero point 4210, and 0.40 z value it will be 0.4284. This please note it. Okay, this will be very useful for future.
What is written below this 0.35?
0.35, it will be 0.3794 error function.
0.379. 0.37 or 0.87?
0.37.
This is 3, no?
3794. So
Then this
between any value of this, we will normally take a 0.
no, 0. What is written below this 0.35? This z like
Z. That's what. Any value between 0.35 to 0.40. You will have to take 0.4210. Okay, now here we are going to take this value only and find the
0.4281. The last one.
4284.
4284. And what is written within this exponential 0 to x exponential minus
Minus u square du.
minus u square d. Okay, thank you.
Now substitute and you will get the answer actually 7.1 hour. Okay. Try to solve it. It will be helpful for you.
What will be the value of C of xt?
C of xt is given 0.80.
This x should be converted to meter, or we can put it in as it is, zero point 0.5
Which one?
mm. X.
Ah, put it as it is. Otherwise, you can convert it into meter and make it. You will get the answer in seconds, and you have to convert it into hours. That's it. That will be fine. So try to solve it and try to get the answer 7.1. Okay.
What is the answer?
7.1 hours.
Actually, within this error function, I am getting this 62500 divided by square root of t.
Okay.
And how can I proceed? 0.5 by 2, 0.25 divided by square root of 1.6 into 10 to the power minus 11. By doing this, I am getting 62500 divided by square root t.
Mm. like detailed answer of this question I will give it in the next class. Okay, like it is very lengthy actually, I didn't include it here, it will take too much time. Otherwise I will upload with the PPT presentation.
That will be good. I mean,
It will
I
be
have
very
stuck
lengthy.
here.
Yeah, actually scanned copy I will upload it, that is the best thing.
Thank you. And also those two portions,
Yes, yes.
compound microscope and theta 1, theta 2.
Compound microscope, what you want? Like
The source, I mean,
there you
if
have to
you
read it, right? And both are theta 1, theta 2 also.
no, I mean, from which book it is taken. I mean, it is not available in this Callister book.
Okay, okay.
No. If you kindly give me the name of that book, that will be more than enough for me.
But I referred from several books, like to get the solving problems, it is very difficult to get it.
Mainly this Callister and Escalade book is preferred for this.
Yes, yes, like that's what I do. For compound microscope, the more
Mhm.
numerical problems won't be there for exam. You can refer the same textbook, whatever it is. But this is very important. And the
Yeah.
first class, theta 1, theta 2 also important. Therefore, our questions are already given earlier years in the
Okay.
previous year.
Okay. Okay. Fine.
Yeah.
ठीक
Actually, these were our earliest years problems, okay? Like last year problems, this and all.
Okay.
Assignment problems only this is. Okay, now next for this question. This question is little bit lengthy, but the formulas you already know. Diffusion flux density. Okay, so the question is methylene chloride is a common ingredient of paints removers. Besides being an irritant, is it also may be absorbent through skin. When using this paint remover, protective gloves should be worn. If the butyl rubber glove are used, what is the diffusive flux of methyl chloride through the glove? Okay, so the data is already given, diffuse coefficient is given, and surface concentration is given, and surface concentration on paint remover and the skin side of rubber glove both are given respectively, and you have to assume that it is a steady state condition. Okay, for example, just imagine this is glove. Okay, now here the paint remover is there, and here your skin. So here one concentration C1, here concentration C2, and the thickness which is given means, okay, is given 0.04. So you have to use the formula J is equal to minus D dC by dt, dAc by dx. That's it. Here also you have to find what will be C2 by C1, C2 minus C1, and X2 minus X1. If you do that and multiply with the D value, you will get the answer. That's it. And for example, I can give the options also. Option A will be 1.16 times 10 to the power minus 6 gram per centimeter square second. 1.16. Option B will be 1.16 10 to the power minus 10. Option C will be 1.16 10 to the power minus 5. Option D 1.16 10 to the power minus 8 gram per centimeter square second. Gram per centimeter square second. Gram per centimeter square second.
1.16 into 10 to the power minus 5.
Minus 5, yeah.
Is it option A?
No, option C.
Okay.
Which option?
Option C. 10 to the power minus 5. Okay, now we will go to the next problem. It is very easy problem for you people. Just you have to find the number of components. At atmospheric pressure, a material of unknown composition shows four phases at equilibrium at 987 Kelvin. What is the minimum number of components in the system? That's it.
Three.
Yeah, answer is 3. So here what you have to use? You have to use Gibbs phase for rules, right? So C minus P plus 2. But here pressure is arbitrary chosen atmospheric pressure. So pressure is you can take it as a constant thing here. So it will be minus C minus P plus 1. So this is your base formula. Now F is degree of freedom. And P is phase and C is component. Okay. So what do you mean by phase?
The homogeneous phase.
Hmm?
The homogeneous phase.
Yeah.
Homogeneous.
Homogeneous in what? Physically or chemically or both?
Both physically and
So phase is both physically and chemically. If you take example like boiling of water, that is a process. So if it is a, what will be the phase in that?
which side you are.
Ice water vapor.
Water
At
and
triple
vapor.
junction.
So the
One,
chemical it is stable or not?
yes, two.
Yeah, both will be H2O, right? Like, okay, so now here, what will be the degree of freedom?
0.
Zero.
By?
Invariant point, triple junction.
Okay, good. Now, what will be the C value? That you have to find it. Now, what will be P value? Phase?
4.
Yeah, 4, which is given in the question. Now, easy to find it. Just you have to substitute. 0 is equal to P minus 4 plus 1. It will be C is equal to 3. Okay? Now, next question. What will be the degree of freedom at the red line marked below?
2.
2. Really? It's not 2. How you got?
Degree of freedom along the line is 1. Along that line.
The question is along the line, okay? So do you know
You go in.
this is which phase diagram?
Water vapor equilibrium diagram.
Yeah, yes. It is triple point water vapor diagram, right? Now, here how many phases are there in the red line?
Okay, 1. Sorry.
Yes,
1.
Two
answer is
phases. Two phases.
2
1.
phases, right?
1.
Yeah,
1, 2.
answer is 1. The question is
Yes,
what
yes.
what I
Yes.
asked is how many phases are here? 2 phases. One is solid and another
Paper.
one is empty. So phase will be 2. Now, what will be the component?
1.
2.
1, 1.
Component will be 1.
Oh, sorry, one component, yes.
Yes, component 1. And your degree of freedom will be then what it is? 1 minus 2 plus 2,
Plus 2.
right? So it will be 1.
1.
Okay, now let me ask one question. What will be the degree of freedom at this point?
0.
How?
0.
There are
Invariant
three phases.
point.
It's a 3 phases. Like,
3 phases.
so instead of minus 2, if we put minus 3, then
Then
how
the
will it
answer will
cancel?
be 0. That is good. So this kind of questions also can come. So 1 minus 3 plus 2 you will get it at the triple point. Okay.
Hmm.
Then it will be 0. Okay, now what about this question?
Eutectic.
Synthetic transformation. It's like a straightforward question. Now let us solve 2-3 normal like numerical problems. Okay. Then we will wind up the class. So see this question. Calculate the vacancy of fraction in copper at 20 degrees Celsius. That is the first question, and second question at the melting point. That temperature is given. Measurement have determined the value of the enthalpy of vacancy of formation, which is given. This notation is different here. It is 1.03 electron volt and entropy free factor A to be 1.1. So how to solve it? Which formula you have to use it? This same kind of problem we solved earlier. it will be similar like this. Okay, like with this notation what we can write it as first we have to calculate like the constant I'm taking a, so a e to the power minus delta hv divided by kt. Okay, so it's everything is given 1.1 time e to the power minus delta h value is also given 1.03, that we can convert it into 1.6 times 10 to the power minus 19 and divided by k value. K value will be 1.38 times 10 to the power minus 22 times, now t value will be, it is in degree Celsius, you have to convert it into Kelvin, so this much. Here you will get the answer for that. So you will get vacancy deficiency at 20 degrees Celsius.
Can you kindly explain it once again?
No, it is same as the formula whatever you are using the earlier problem. See, this problem what we use same. Okay, just notation is changed in the question. That's it. Okay, where here we are using n, that I not just simply represented as a. That's it.
1.03 into
And this
1.
is I converted into electron volt, like
Okay, fine,
electron
fine,
volt to
fine.
normal, like volt. We have to multiply the electron E value.
Okay, fine, fine. Thank you.
Then here the unit will be in the centimeter. That's why I use the value of K will be like this. Okay, 1.38 into 10 to the power minus 22.
Okay, say again.
No. Normally we will using normal SI unit, right? But here the problem, like I solved that is in centimeter. That's why I given the value here, K value like this.
Centimeter. I'm not getting actually.
No, what will be the unit of K?
Electron volt per Kelvin.
So normally which value you are taking for K?
8.62 10 to the power minus 5.
Yeah. So this will be for this 1.38 times joule per Kelvin. Okay. If your value of K converted into joule, it will come like this.
Okay. Joule per Kelvin.
Yes.
So, okay. Thank you. And this 1.16 into 10 to the power minus 19 for?
That is converting electron volt to normal. That electron what charge is that 1.6.
Okay, fine. Thank you.
So how much you are getting answer? should get the answer 2.19 times 10 to the power minus 18. Okay. Similarly, you have to calculate same for temperature 1085. Same formula, you have to calculate that also. Just change the temperature here to 1085, then you will get the answer. It should be 1.67 times 10 to the power minus 4. Please check it, okay? And here it's our vacancy fraction. So take the fraction of like this function 1085 divided by 20 degree. Then you have to find the total and final answer will be 7.262 times 10 to the power 30. This should be your answer.
Hello, ma'am.
Yeah.
I have doubt with the assignment 3 last question. So, shall I read out the question?
Yeah, please read it.
A diffusion is the result of dash. The options are concentration gradient, chemical potential gradient. Option C, both A and B. Option D, neither A or B. So, what will be the answer?
What is option A and B?
Concentration gradient.
Hmm.
B is chemical potential gradient.
Both of them.
Both of them are answer. Yes.
Both of them are answer,
Hmm.
yes. But in the correct answer section, they have given chemical potential gradient.
No, definitely first option also answer. Okay, I will email to them. Okay.
Okay.
Yes.
I didn't raise query about that question
But
because I'm
please
not
raise
sure
it from
what.
your side also because
Yeah,
they
okay,
should.
okay, I will do it. I'm a little unsure about the answer.
No, no, both are correct. Okay.
Okay. How many more questions are there?
There are two, three more questions. If we didn't finish by today, we'll solve it in next class. That's it.
Oh,
So this portion is very important.
Yeah, that will be good. Next class.
Yeah, we'll solve one more problem, then we'll finish it. This one, last one. This is also same formula. You have to use NV is equal to N times. See the question, an iridium, the vacancy fraction NV by N is given at the temperature and at the melting point. Calculate the enthalpy of formation delta HV. Okay, there is nothing but NV divided by N is equal to 8 times e to the power minus delta HV divided by RT. That's it. So here two situations are there, like one you have to write 3.091 times 10 to the power minus 5 is equal to 8 times e to the power minus delta HV divided by RT1. That here T1 will be 1134 degrees Celsius. You have to convert it into Kelvin. So it will be 1507 Kelvin. Okay, and another one is 5.26 times 10 to the power 3 is equal to a to the power e to the power e to the power minus delta HV divided by RT2. Okay, here your T2 will be 2446, that will be 2719 Kelvin. Okay, now you have to take the ratio of both. A will be cancelled and take the log, then find the final answer delta HV. Okay, or you can take it as the value 8.314. Please try to find it.
What is the value of this T2?
T2 2719. Okay, at the melting point it is given. The melting point of iridium is 2446. Okay. In exam it will be given in the bracket. What is the value you are getting while dividing 3 point, means you have to divide it. This is, you can call it as equation 2. This is 1 dividing 2 by 1. Okay, that will be easy. So you should get log 170.2 is equal to delta HV divided by R 1 minus 1 over 1 by T1 minus 1 over 1 by T2.
What is the answer?
Answer will be um, 2.40 times 10 to the power minus 19 in joule. Otherwise 1.5. I'll write it. Delta HV will be 2.40 times 10 to the power minus 19 joule per vacancy. Okay. Otherwise, you can write it as in 1.5 electron volt per vacancy. So while solving this, actually you will get the answer delta HV value. Okay. You will get the answer 1.44 times 10 to the power 5 joule per mole into vacancy.
One point four four. Getting 1.83 into 10 to the power minus.
Minus you won't get it
Check. 1.44.
because it will be like okay, I'll add one more slide. It will be like you will get delta HV is equal to minus 8.314 times log 170.2 divided by 1 over 1507 minus 1 over 2719. If you solve this, you definitely will get 1.44 times 10 to the power 5 joule per mole per vacancy. Okay, now per mole we have to move it, so for that we can do delta HV is equal to 1.44 times 10 to the power 5 divided by per mole Avogadro number we have to divide it, so 0.6.02 times 10 to the power 23. There you will get the answer 2.40 times 10 to the power minus 19 joule per vacancy. That you can convert divided by 1.6 times 10 to the power minus 19, you will get 1.5 electron volt per vacancy. That's it. So just we'll finish two more problems are there actually. One is related to same kind of problem, and another one is related to some schematic drawing. So what we will do, we will solve that is next class. So here what we discussed today is only based on the diffusions, like the third week class, defect, diffusion and phase diagram. Okay, so normal theory problem all will depends only when whatever are taught in the classroom. And here the problems are related to, one is for this equation nv by n is equal to the power minus qv divided by kt, and another one is this phase rule, that is j is equal to minus d divide d dc by dx. And another formula is this one, d is equal to diffusion formula, d is equal to d0 e to the power minus q by rt. If you know these three formula, you can clearly solve all the problems related to this portion. And here you have to remember two three things. One is Avogadro number, another is r value, then another one is Boltzmann constant k value. Okay, these three you have to remember. Sometime it will give in the problem, otherwise you have to remember 8.314 the normal values. And please read more like please listen the class about and then same formula I put d plus k minus t plus c. This is also very important addition.
Ma'am, excuse me, ma'am.
Yes.
Actually, I have a doubt in this assignment 3, which we have submitted on February 13. The question is about these solidus and solvus lines. Can you explain me that? That solidus and solvus line.
Can you check the chat box first? Solidus versus solvus.
1 minute, ma'am. Uh,
Now she's asking what is solidus and solvus line. What's the difference between these two?
Yeah, yes, exactly, ma'am. I'm asking that. There was a question which says how, in the assignment 3, there is a question which says how the solidus, what is solidus and solvus line. So what I perceive is the solidus line is between a solid and a mixture which contains a liquid.
No, that
And they,
solidus line is the line on the phase
okay.
diagram. Okay, which is
Uh,
below which is only solid is present. So for this
be,
problem, then only you can tell it as the solidus line.
okay, below which only solid is present.
Yes,
What about the solid means a solvus line?
solvus line.
Yes.
It's the line that gives the maximum solubility or solute in this
But
line.
If I'm not wrong, it is the phase boundary between two solid phases.
Yeah, you can say like that also.
Yeah.
But
The ideal
according to the
example of an
SAS
aluminum
lecture,
system.
according to SAS lecture, he told it's the maximum solubility.
Yeah, yeah, yeah.
Solvus line is the line where we can see, means check the maximum solubility. In the third assignment, there is a question like, I think it is question number 12. Solidus and solvus line are the boundary between dash.
can the option is given?
The option A is liquid and liquid plus alpha, and alpha plus beta respectively, like that. Can I share my screen?
Actually, the answer is none of the above. But the answer,
Yes, that is
but the
what I
accepted
found.
answer
The
is
answer is none of the above. But for
Okay,
me, when I
option.
check the answers, it is showing like option A. So I got confused. That is why I'm asking.
Yeah, yeah. Answer will be none of the above. Sometimes we have to happen. Okay, some the answer which is given is wrong also. See, like this type of question, right? Solvus line
Yeah,
and solvus.
exactly. So the solvus is between alpha and alpha plus beta.
Yes.
So what about the same for solidus? The question is like it is asked for both the things,
Okay,
solidus and solvus line.
yeah, then you cannot give answer in this.
So for solidus, I think it is like beta, means the option B is for solidus.
Beta and L plus beta, right?
Ah, but the option A is like L and L plus alpha. So actually the answer is none of the above, but it said it is wrong. That is how I got the answers.
Solidus will be,
Beta and L plus beta.
or alpha and alpha plus
It can be alpha and L plus
L plus
alpha also.
alpha.
That is also there.
Otherwise, beta and L plus beta also.
Yes, yes. Both will be right.
But cannot simultaneously answer also.
Means I didn't get you.
The question is like solvers line and solidus line, right?
No, no. It is like solidus and solvus line are the boundary between.
So boundary solvers like that, right? For solvers. So even
They are given two different options. For solidus also they are given, solvers also
oh,
they
then
are given.
maybe you have to select two options then.
Yes,
But
no, no.
did they
In
give
each option they are given. In each
did they
option
give
they are given.
respectively something like that?
Yes, 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 ma'am. Yes.
Okay, okay. Then you have to select. The question is not a flip like a question. Okay.
So can you see in means in my thing I am showing that question rather than my picture. I am showing that question to you.
Here.
Yes. It says like this: solidus and solvus line. If I keep like this,
Question is written like that. No, the answer is nothing is there, right?
yeah.
Okay, please write the like comment on chat. Okay, NPTEL.
Okay, okay, okay. Thank
I have
you.
raised I have raised queries for three questions in another
Okay,
discussion.
okay, fine. I will also email the
Okay,
question like all over the NPTEL team. That
okay, ma'am.
they are checking your answers before they are
Yes,
sharing.
yes, ma'am. Okay, thank
Okay,
you.
okay. Thank you, ma'am. Thank you for your patience.
Yeah. Okay, so we will solve 2 3 problems are remaining. Next class we will do and next class according to the quarterly problems also we will do. Okay. So hope you
Okay,
are
okay.
okay with the problems and answers what you are solving.
Yes, ma'am. Yes, yes, definitely.
Okay, then
Thank
see
you.
you